Hi, I'm Aishwarya. Over the past 8 years, I've spent most of my career building cloud infrastructure, identity platforms, and security automations. One thing I kept noticing was that authentication isn't usually where the identity problems begin, it's where they become visible. The difficult part comes afterwards. Understanding why an access decision was made, what policy influenced it, and what happens if that policy changes tomorrow. That's the problem I built this project around. So, what you're looking at isn't a mock authentication flow. It's a working policy decision engine integrated with live Okta tenant. And the objective here wasn't to build another login experience. It was to make security decisions explainable. Because that's usually the conversation security teams end up having with the customers. Let's frame the customer before we touch the product here. Imagine a financial service company with around 1800 employees. They have hybrid Active Directory, Azure AD, and the users are remote folks, and they have a new CSO. Recent credential stuffing incident that has happened. So, on paper, they have already invested in identity. The real question isn't can we authenticate the users? Rather, it is if this exact login happened from a Tor exit node instead of a corporate office, then what changes? Access is no longer a network decision. It is a request by request risk decision. That thinking shaped the architecture. Authentication happens through a live Okta tenant using OpenID Connect. Everything you'll see in the identity context panel, the authenticated user, groups, MFA method, and authentication path, is decoded from the ID token Okta has just issued. Nothing is manually populated. Once identity is established, the policy engine evaluates multiple independent signals: identity, device posture, network trust, time, requested resources. So, rather than producing a simple allow or deny, every applicable policy contributes to the final decision. And that separation was intentional here. Authentication establishes the identity, and the policy engine explains the trust. So, the demo is pretty straightforward. First, I'll authenticate against the live Okta tenant. Then, we'll evaluate a normal access request here. We'll then change the operational context and watch the policy decision change. Finally, we'll look at something I think is even more useful than the decision itself. It is the impact of changing security policy before it reaches the production. All right. The first thing I'll do here is authenticate. I have my Okta domain and client ID already. And this takes me to the Okta login page. So I have some users created here under different categories: admin, contractors, and engineers. So right now I'm going to log in as one of the admin users because he's the CEO here. And which is MFA enabled. Everything inside the identity context panel comes directly from the issued ID token, the role, the group, the MFA status, authentication method, and all the details here. They are decoded live from Okta. So next comes policy evaluation. Here, I get a detailed context around everything. So, every user is evaluated against multiple independent controls. So, manage device requirement, Tor exit node detection, MFA enforcement, and privileged resource protection. Here, each policy contributes to the final decision, which means I can change one condition and immediately understand why the outcome changes. And that's much more valuable than a simply returning access denied. One screen I particularly like is policy impact view. Here, instead of asking, can I enable this policy? It answers the operational question: what happens to my environment if I do? I have a recommendation suggestion here as well based on each policy analysis. So here are my users from Okta which are loaded, and what are the rollout recommendations for every option. Here we can see exactly how many users would lose access, who would require step up authentication, and who would remain unaffected. For example, this user is blocked, and reason being it's a read only, the MFA is none, and device is unknown. We have users based on each group's finance, admin, engineer, contractor, and MFA option which they have enabled. For an example, this contractor role needs to step up, reason being MFA is SMS enabled and needs action there. That goes for other users as well who are blocked, step up, and who has no change. And receive a rollout recommendation as well before making any production changes. And that is a conversation security teams actually have. Compliance mapping continues the same idea here. Notice that not every framework control is fully satisfied. For example, CIS 5.2 is marked as partially implemented. That isn't a limitation of the demo, that's intentional. Real environments are rarely 100% compliant, and a usable platform should surface those gaps honestly. Finally, we have the executive dashboard. The activity shown here represents a simulated third day operating window. The metrics is seeded, but the workflow is representative of how policy decisions roll up into operational reporting, MFA adoption, blocked request, and executive level security trends. So, what interested me while building this wasn't authentication. Authentication is a solved problem. The interesting engineering challenge begins after identity has already been established, how policy decisions are evaluated, and how they are explained, how their operational impact can be understood before rollout, and how those technical decisions eventually become something both engineers and business stakeholders can trust. That's what Identity Access Studio is built to evaluate. Thank you for watching the demo. See you again. Bye.